Hello everyone. In this lecture, we'll be studying Class A transformer coupled amplifier. So let's draw the diagram of transformer coupled amplifier first for Class A. So this is my BJT. Here I'm using a transformer coil, and this is my BJT here. This is my RE resistance. Here I'm connecting it to ground. This is my bypass capacitor CE. Now here at the input side, I'll be applying a voltage divider biasing using the resistor R1 and R2. And this is connected to ground here. Here I'll use a coupling capacitor capital C, and I will apply my input here at this point. And this R1 will be connected to VCC DC power supply. This is my primary of the transformer where my input here is V1. Number of turns here is N1 and the current flowing here is I1. Similarly, the number of turns in the secondary is N2 and the voltage here is V2 and the current supplied is I. Let's say I'm using a loudspeaker here as a load. So this is my load here. So we are using a transformer coupling here in the Class A transformer coupled amplifier. Why do we use this Class A transformer coupled amplifier? Because we want to improve the efficiency. Because in the last case where we were using emitter follower transistor Q1 being supplied by a constant current I using transistor Q2, in that case your efficiency eta maximum can go till max 25%. So in order to improve the efficiency, we will use this transformer coupled amplifier. So in this transformer coupled amplifier, since we are using a transformer, so I should write down the equation of transformer, that is V1 by V2 is equal to N1 by N2. That is primary input to the secondary input is nothing but equal to the turns at the primary to the turns at the secondary. This is my equation 1. Similarly, I'll write another equation for transformer, that is I1 over I2 is equal to N2 over N1. This is another equation for transformer which is giving you the value of current at the primary winding to the current at the secondary is equal to the number of turns at the secondary to the number of turns at the primary. Now I will divide equation 1 and 2. When I divide, I will get the equation as V1 over I1 to the value here as I2 over V2. That is equal to, here you will get N1 square. So N1 upon N2 whole square on the right hand side. Now I can write this as V1 over I1 is equal to, this V2 goes here. So V2, this I2 comes down here. I2 into N1 by N2 whole square. So this is my equation which I got. Now this V1 over I1 is nothing but, we call it as effective load resistance. I will represent this by RL dash. At the primary I am talking. So V1 by I1 is at the primary, which is called as RL dash. Similarly, V2 by I2 at the secondary, we call it as load resistance, which is RL, because V2 by I2 is nothing but across the load. So I can write this same equation as this also. RL dash is equal to N1 by N2 whole square into RL. So this is my one equation which I got from here. Now here I will be drawing a load line. I will be drawing a DC load line and an AC load line here. So this is my AC load line. This is my current. This is my current. This is my voltage. This point where it cuts is to VCC. This point where it cuts, this coordinate is 0, RAC. This RAC is nothing but the AC resistance of the primary winding here. This primary winding here. So, and we are assuming the DC resistance of this primary winding DC resistance is nothing but 0, and AC resistance of the primary winding is nothing but RAC, which is here VCC by RAC. So this is your AC load line. Now I will draw a DC load line. Since the DC resistance of the primary winding is 0, so the DC load lines will be vertically drawn, and where it cuts is VCC, and the point where it intersects with the AC load line, that is your ICQ. So the intersection point of DC load line, this is DC load line and this is AC load line. So the point of intersection of the DC and AC gives you the Q point. So we call it as quotient point. Now here if I want to see the output will look like this, which can have the maximum value, that is Vm is equal to VCC. Why? Because this is 2 VCC, this is VCC. 2 VCC minus VCC is VCC. So maximum output swing in one of the cycle will be VCC. Same here also. This is also VCC. Now using this DC and AC load line, I will be calculating efficiency now. So efficiency will be nothing but equal to AC power delivered to the load, that is PAC, to the AC to the DC power supplied, so PDC. So that is again PAC is nothing but VRMS into IRMS divided by PDC is nothing but, here in this case your supply voltage is how much? VCC. So here I will write VCC into, or I can say this curve also, the point Q point is nothing but this one, where your coordinate is VCC comma ICQ. So VCC comma ICQ gives me the value of PDC. Now in place of VRMS I will substitute as your Vm by root 2. Vm is nothing but the maximum value, Im by root 2, maximum value by root 2. This is nothing but VCC into ICQ. I'll write ICQ here. Now Vm I can write it as, Vm is how much here? I wrote here VCC. So VCC into Im I can write as ICC. ICC means the maximum value of ICQ is nothing but the maximum value of current which will be flowing here. So that is nothing but ICC divided by 2, and this is VCC, and this ICQ, this point is the nothing but the DC bias current or constant current flowing through it. So this ICQ is nothing but ICC. So I will write this as ICC here. I will write this as ICC here. ICC cancels with this, VCC cancels with this comes to be 1 by 2 into percentage. If you want to calculate into 100, you'll get this as 50%. So eta comes to be 50%, maximum comes to be 50% if you use a transformer coupling AC. If you use a transformer coupling in class A, your efficiency increases to 2 times to 50%, or it can get doubled. But efficiency will not be exactly 50%, it will always be less than 50% because of the usage of the two biasing resistors R1 and R2, which causes a voltage droppage. Power dissipation will happen across these two resistors. Because of this, efficiency reduces and it will always be lesser than 50% in this case. Now this kind of amplifier class A, class A transformer coupled amplifier is used in the output stage to supply adequate power to the transducers, such as like loudspeakers in audio amplifiers. So this is about your class A transformer coupled amplifier. In the next video we'll be looking at class B transformer coupled amplifier. If you like this video, subscribe my channel. Thank you.